This is the magnetic chain reaction exhibit. Mounted on top of the table are 8 discs, each with a bar magnet. These are protected by an acrylic cover. When you turn one end of the magnets, what happens? It looks like the other 7 magnets are affected by the magnet you turned. Touch the other end of the magnets and turn it too. It seems that it works for either end of the magnets you turn. The other 7 magnets always turn too. Which part of the magnets are involved in the effect you are observing? The magnetic force surrounding a magnet is not uniform. There exists a great concentration of force at each end of the magnet and a very weak force at the center. The 2 ends, which are the regions of concentrated lines of force, are called the poles of the magnet. One pole of the magnet is the north-seeking pole. The other pole of the magnet is the south-seeking pole. The pole of a magnet will always be attracted to the opposite pole of another magnet and will show a repulsion to the same pole. In the exhibit, 8 bar magnets are placed, one after the other, on the table. Each bar magnet is secured to the table, but is free to rotate at its center. When one magnet is rotated, its poles will either attract or repel the poles of the magnet beside it. This attraction or repulsion will cause the adjacent magnet to rotate too. Its own magnetic poles will attract or repel the poles of the magnet beside it, which in turn causes this magnet to rotate too, and so on and so forth. The attraction or repulsion between 2 magnets makes the row of magnets in the exhibit move in a chain reaction. This exhibit demonstrates the law for magnetic poles. Like poles repel, unlike poles attract. Magnetic repulsion is now used in many fields of industry. Magnetic repulsion can be used as a braking mechanism for motors. Because there are no frictional surfaces, these kinds of brakes do not wear out easily as mechanical ones. Magnetic levitation vehicles are operating on the concept of magnetic repulsion to levitate the train on its track. This eliminates friction so that the train can go very fast with minimal energy consumption. Mechanical engineers can also use magnetic attraction as clutch systems for contactless attachments to motor drive systems. When a mechanical failure happens on the driven end, the motor can still rotate freely when the magnetic clutch disengages. This protects the motor from harm.